You know that feeling when your software project just feels stuck in chaos? Like you're constantly putting out fires instead of actually building cool new things? Well, today, we're going to dig into some ideas from John Gilbert's work on architectural patterns that are designed to fix exactly that, to build systems that actually give your business a real competitive edge. All right, so let's jump right in. We're looking at a summary of software architecture patterns for serverless systems. And really, this is all about one thing: how to get away from that chaos and build a system that's truly designed for fast, non-stop innovation. So let's kick things off by exploring a problem that I think a lot of us in the software world will find painfully familiar. It's kind of like a tale of two teams, two very, very different ways of getting things done. And this really gets to the heart of it, right? Why is it that so many projects just feel chaotic? That constant pressure, always fighting fires, scrambling to hit deadlines while requirements are changing at the last minute. What's going on there? The book comes up with this absolutely brilliant analogy. It compares that whole chaotic process to one of those reality TV shows, where a team has to build a custom motorcycle from scratch. It's all about the drama, the vague requests from the client, a totally unrealistic timeline, and then that last-minute scramble to just get something out the door. Yeah, sound familiar?
But here's where it gets really interesting: the contrast. So forget the chaotic bike shop for a second. Instead, picture a high-performance Grand Prix racing team. What do? They live and breathe on super-fast feedback loops. They're constantly fine-tuning everything, making tiny improvements after every single lap to squeeze out more performance. Now that's the model we're aiming for.
Okay, so how do we do it? How do we make that leap from the drama-filled motorcycle shop to that elite racing team? The book argues that the entire answer really boils down to one single powerful idea. And this is the absolute key. You can say your teams are autonomous all day long, but if your architecture forces them to have a meeting and coordinate every little change with 3 other teams, well, that's not real autonomy, is it? It's just an illusion. The real freedom to move fast and innovate has to come from the software architecture itself. It has to be designed to let teams be independent. And that brings us to the core building block for this whole approach: the autonomous subsystem. Just think of it like this. It's a completely self-contained part of your system that handles one specific business job. Maybe it's the user profile service or the product inventory service. The point is, the team that owns that subsystem can change it, deploy it, and innovate on it whenever they want without having to ask for permission. Now, to actually make all this work, you need a bit of a mind shift. It's called event-first thinking, and the steps are laid out right here. You start by mapping out what actually happens in the business, the events. You treat those events like facts that can't be changed. Those events then become the contract between your different services. And the final piece, you connect everything up asynchronously. That is the secret sauce that truly decouples your system. Okay, so that's the mindset. But how do we actually put it into practice? Let's open up the Architect's Toolkit and look at 3 key patterns that help us build this autonomy across the entire system. We're talking back-end, front-end, the whole shebang. First up, we've got domain-driven design, or DDD. Now, this isn't some brand new idea, but it is absolutely essential here. DDD is how we draw really clear lines in the sand, creating boundaries around the different parts of our business. These are called bounded contexts, and they basically become the perfect blueprints for those autonomous subsystems we were just talking about. All right, so we've used DDD to draw our boundaries on the back end. Now we take that exact same idea and apply it to the user interface. So instead of having one giant clunky monolithic front-end application, we break it up into what are called micro front-ends. Each little piece can be built and deployed all on its own by its own dedicated team. And the benefits of doing this are just huge. First, any changes you make are isolated, so one team's bug doesn't crash the whole app. Second, you can lazy load parts of the page, which makes the whole thing feel way faster for the user. And maybe the coolest part? Teams can actually use different frameworks if they want, letting them pick the absolute best tool for their specific job. And for our third pattern, we have to tackle the big one: data. The book talks about this really powerful, almost physical force called data gravity. The idea is that as a database gets bigger and bigger, it starts to pull everything towards it. It becomes this massive center of gravity that makes any kind of change incredibly difficult because so many different apps and services are stuck in its orbit. It just kills innovation. So how do you fight something like data gravity? The secret weapon is a pattern called CQRS. It's a really elegant idea. You basically split your data operations in 2. You have one path, the commands, that is purely for writing or updating data. And then you have a totally separate, highly optimized path, the queries, that's just for reading data. It's this clean separation that finally breaks your teams free from the pull of that giant monolithic database. Okay, so these patterns are really powerful, right? But theory is one thing. How do you make all this stuff work safely and reliably out in the real world, in production? Let's get into the operational side of things. When it comes to security in an architecture like this, you really have to think in layers, a defense in-depth strategy. Think of it like a castle. Your secure cloud accounts and CI/CD pipelines are the high outer walls. Inside, you have strict user access controls, kind of like the inner keep. And patrolling the walls, you have your continuous automated audits acting as watchtowers, spotting trouble early. It's all these layers together that create a truly safe space for teams to work.
And the way you deploy code changes too. It's a total philosophical shift. Instead of being terrified of failure and trying to avoid it at all costs, the goal becomes to fail forward fast. What does that mean? It means you build a system so robust that teams aren't afraid to deploy new code all the time. They know that if something does go wrong, they can spot it instantly and roll out a fix in a matter of minutes, not days.
And finally, let's talk about the glue that holds this entire approach together: observability. None of this autonomy works unless teams can see what's happening. When you give them deep insights into the health of their services, the performance, and even how much it's costing, you're giving them the power of self-governance. They can make their own smart, data-driven decisions and constantly make their little corner of the world better. All right, let's step back for a second. We've talked about the problem, that feeling of chaos. We've talked about the solution, building for autonomy. And we've looked at the patterns that make it happen. But what's the big picture here? What does this all really mean? And here it is, the most important takeaway of all. Your software architecture isn't just some technical diagram that engineers care about. It is a fundamental strategic business decision. It is the very foundation that will either enable your company to innovate and move fast or hold it back, trapped by its own complexity. And so that leaves us with one last question, a pretty important one to think about when it comes to your own systems. Is your architecture empowering your teams to perform like that high-speed Grand Prix crew? Or is it forcing them to scramble around in that chaotic, high-drama motorcycle shop?